Hello everyone, I am Arun Babu and welcome to my video presentation of homework for week 16 on first come first served queues with the two classes of impatient customer. So let's go to the content of this video presentation. First of all, we will check the task description, then FCFS system approach, and then we will check the MG1 plus M system and MMK plus M system, and then we will do some numerical analysis and finally the conclusion. So the task description is to analysis of the paper by Ivo Aiden, Brett Hathaway and Vidyadhar G. Kulkarni on first come first served queues with two classes of impatient customer and present the findings of that paper. So what is an FCFS system approach? So here we will analyze the performance of FCFS system with the two customer classes that may differ in both their distribution of service time and their distribution of patient's time. In an FCFS system, the customers are served on a first come first served basis regardless of their classes, and analyze two systems as MG1 plus M system and MMK plus M system using a queue length process. So this is MG1 plus M system. It is a single server model. We can see only one server here. So here I of 1 comma 2 represent the impatient customer class, and lambda I is the arrival rate of the customer, gi is the service time of the customer, and the service time is independent and identically distributed, and theta I is the patient's time. Here the customers are impatient, and customers from class I leave the system after an exponential amount of time with parameter theta I if their queuing time is longer than their patient's time. And for each customer the patient time is different. And this is MMK plus M system. It is a multi-server model. So here we can see number of servers. So here also I have two classes of customers. I of 1 comma 2 is the customer class, and lambda I represent the arrival rate, and the service time is exponentially distributed. You can see exp of mu I, and the patient time of the customer is exponential of theta I. And if the service does not begins before the patient's time run out, the customer will turn away. And let's check the go to the numerical analysis of this system. Here we are going to compare the performance of three systems over a range of system load, and those three systems are base system, positive system and negative system. In all these three systems, class 1 has a mean service time of 1 unit, and class 2 have a mean service time of 0.5 unit. In the first system, that is in the base system, the customers in both classes are equally patient with a mean patient's time of 2/3 unit. And in base system, customers from the two classes differ in their distribution of service time but not in their distribution of patient's time. And in the second system, that is in the positive system, mean patient time of customer in class 1 is 1 unit, while the mean patient time of the customer in class 2 is 0.5 unit. And in the third system, that is in the negative system, the patient time of class 1 customer is about 0.5 unit, and patient time of class 2 customer is about 1 unit. And in each cases, the arrival rate of the class 1 and class 2 customers are equal, that is lambda 1 is equal to lambda 2. So here we are going to check some graphical analysis. So the first graph, that is the graph A, represent the percentage of all customers receiving the service. So here the black thick line represent the positive system, and the dotted line represent the base system, and the hash line represent the negative system. So here the percentage of all customers who receive service is lowest in the positive system and highest in the negative system. And class 1 customers are more patient than class 2 customer in the positive system and vice versa in the negative system. And the second graph, the B graph, is the mean waiting time of all customer. So here the customers have the highest mean waiting time in the positive system, and mean waiting time of the customer in the base and negative system are almost equal in this graph. And the C graph is the system throughput. Here also we can see that customer receiving the service is lowest under the positive and highest under the negative system. So positive system throughput is first increasing in the arrival rate, but is then decreasing after some threshold arrival rate. So it's clear that some at the beginning of the arrival rate, the positive system increasing, and at some point, that is some threshold point, it will start decreasing. And the last graph, or the D graph, is the average service time. Here we can find that the base system average service time is almost constant at all the arrival time or all the arrival interval, but for the positive and negative system it's different. For the positive system, average service time is increasing, and for the negative system, average service time is decreasing as the arrival rate increases. And the reason for the base system to remain constant is because the customers in each classes are equally patient. And the conclusion is that when analyzing an FCFS system with multiple class of impatient customer, we can find several managerial implications. Thank you for your attention.